Guess what this video is all about? It's about tolerances. Someone's asked us what tolerances we use when we're making stuff. There's no simple answer to that. It depends on the material, the application, where we're at. So these are the RDS adapters and actuators and plates that we use. So this is an aileron internals for the Mustang.
Show me the plates, sort of flatter. Yep, made out of carbon fibre board.
So this is 4.78mm piano wire, and we want to fit in there that's just tight but not ridiculously tight. So these are actually 4.7mm apart between them.
Into the light's good, yep.
In there. So when this goes, so when we cut these ribs that space these rubbing plates, 4.7 to basically a 4.8 piano wire, so it's just a nice fit. So in this application, that 0.1mm tolerance is fine. Other applications, very different. When we're 3D printing, something like a 0.3mm tolerance is so that gives this gap between the support and the exhaust. So that'll sort of pop off. It's holds it enough, just pops. So that is a 0.3mm tolerance between the support and the actual 3D printed part. When you do, so we've got a wing joining tube, which is 32mm 6061 aluminium, and we make sleeves to go in the wing. So when we make the sleeve around the tube, we use 2 bits of paper, a 0.2mm tolerance, which gives a nice sliding fit. No slop, but it's certainly not going to bind up either. So that's a 0.2mm tolerance. When we cut plywood parts, aluminium parts, and aluminium fit to plywood parts, that took, it's a lot of trial and error. You've got to have a guess, go cut it and see if it works. So what we've ended up to get this sort of fit, like this is totally unsanded, totally unfettered. It's, so the fit, you want it to be firm but go in without any sanding. So the way we do that, we do 0 tolerance in the drawings. The drawings are exactly as you draw them, but the bit that we use to cut this is actually a 1.56mm bit, and the when we do the tool path, we tell it it's a 1.5mm bit. So all these holes and outlines are overcut by 0.06 of a mil, which gives us a 0.1mm tolerance, like on an inside shape, which gives us that fit that just, it's sort of loose, but it stays there. Like it's a very firm, positive fit, but there's no sanding and fettling to make it all go together in the first place. This led on to doing a new fuel cap for the new Mustang. So I've had, in the past, we've just had these caps go into the surround. The surround goes in the back in there. Come around that side. And screws in, holds in there, and the cap goes in and then locks through this slot, if you like. In the past, we've just had that as basically a tolerance fit, so that the friction would just hold it there. Occasionally it did come out, which is not good. So we're watching a YouTube video, we'll show you the link to that soon, where they came up with the idea of just having just a slight little knob in there, so that when this goes in, it goes in like really easy fit, but when you turn it, it turns easily, but then you get to this little click, which holds it in there positively, and then click comes out. Cap goes down. So that's made up of these parts. We used to 3D print this, but real pain printing nylon filament. So we just cut this out of HDPE, like a sheet of HDPE, 16 mil. So there's the top part of the cap. That's the little brass handle on the top. This is the ring, and this is the working bit that does the locking. So I'll show you on the computer, but this ring fits over there, like really loose fit tolerances, but just at that pinch point is a click. There's this little knob just on either side, which just gives it that little clip, which makes that so much more functional. That's never going to come out, but it's easy to get out when you want it to, but stays there. So the tolerances of that was actually of 1 mil tolerance. We'll show you that drawing on the computer. This is the drawing for these parts which make up the cap. So the light blue, can you zoom right in on that? The light blue is the piece with the little locking tab on it. So these two tongues, which are in the surround, are the yellow bit, and the bit with the little locking clips is the light blue. So you can see how that like slides in. The tolerance here is like 0 tolerance on this, but just the cutting process, there's enough chatter just to give you just that slight loose fit. And as this thing comes round, it hits this little pointy knob, or 2 pointy knobs, and clips in. But material is so flexible that on the computer that looks ridiculous. It's a 1 mil. That's a 1 mil 1 mil
distance, little like peak.
Yeah, little knob on the end of it, but the material is soft. The tip is knocked off in the first couple of times, but it finds its own level and makes a really positive fit. So in this case, it's a 1 mil tolerance because that works for the application and the material. Highly recommend the YouTube video by Angus on Maker's Muse. Australian, designing for 360, but talking about tolerances and design concepts. Some brilliant content on there if you want some easy listening.
Yeah.
Onwards and upwards.